As a layer 4 technology, because for layer 1 we talked about cables and bits, for layer 2 we talked about MAC address, for layer 3 we talked about IPv4 and IPv6 address, etc. And now for the layer 4 actually, we will talk about the TCP and the UDP, because these are the two most famous protocols used on that layer, on layer 4, to transport your data. So these two will be the carriers or the protocols. These two are protocols actually responsible for carrying your data based on their criteria, based on their mood, based on what they think that data should be transported on or transmitted on, which criteria. Yeah, it's based on their terms or conditions. So the first one is called the TCP, the Transmission Communication Protocol. This one is reliable. If you send your data from your computer to another computer and you ask the application to be developed actually, or to send your data using a TCP window, then the data will be definitely reliable to be sent, but it will be very slow. So the other end might wait a little bit, like microseconds, milliseconds, or really seconds sometimes. Let's say not a minute, not in that way, before it can receive the data that you send to. Why? Because TCP uses something called a three-way handshake, and that is simply your computer and the other end computer should be connected somehow together through device, internet, multiple devices, multiple planets in the way, whatever. So the idea will be that if you ask the application to send data by using TCP, then the application will do something called the three-way handshake, and that is, it will first send something called a TCP synchronization message, the SYN. I should type the name of the flag actually. It's called a flag. So it's a TCP flag called synchronization flag. So it's asking the other end, hello, is anyone there? I'm tending to send something to you. If the other end responded, then it will respond with something called the synchronization is acknowledged. Yes, we are there. You are welcome to send something. Then you will, as a polite matter, you will say, well, your acknowledgement has been acknowledged, so thank you. That's why it's called a three-way handshake. So I asked you, are you available? You reply to me, yes, I'm available. Go ahead, spit it out, whatever you want to say. And I said, okay, thanks for confirming. After that, after this entire process is successfully achieved, completed, fulfilled, then your computer will send that image or send that email or send that data or file to the other end. For every session to be established between two devices and the TCP should be used, then this process of three-way handshake will continuously be repeated. That's why it's reliable, and that's why this type of connections is called a connection oriented. Some methods or some famous examples of TCP or applications developed or services or protocols developed using TCP is HTTP, because it uses the destination port of TCP 80. So when you send a packet or you send something, the packet will be encapsulated inside a big inside the packet there will be a small segment. Inside the segment there will be something called source port and destination port. If the destination port was filled with number 80 only, so like when you are sending a bits, the bits are representing frames. Inside each frame there is a destination MAC and a source MAC, and there is a packet encapsulated. Inside the packet there is a destination IP and a source IP, and there is a segment encapsulated. Inside the segment there is a destination port and a source port. So only if that destination port was like 80, then the computer and the carrying developers and the carriers in the way will understand that the destination is an HTTP browser, web browser. So you are establishing a web browser connection. You want to visit a web page. This is the idea. If the destination port was 443, then it's not an HTTP, it's an HTTPS, only secured HTTP. If it was 20 or 21, then it's FTP. SSH is using 2020, Telnet is using 23, SMTP for emails is using 25, Protocol BGP is using TCP 179. So these are famous examples that I don't expect you to know any of them in chapter 1 of CCNA. You will start to know them in chapter 3, 4, 5 of this course, and in chapters 2, 3, 4, and 5 in the 2, 3, and 4 in the CCNP in core course as well. So you will start to know them, but these are just famous examples. But this is so reliable, so slow. If you want things to be very fast, and if you don't want that three-way handshake process to happen for every single session, seriously, sometimes you are really on a hurry, on emergency, you need things to be transported extremely fast, then you might need to use the user datagram protocol, the UDP. The UDP is not reliable. Why? Because no pre-steps performed. If I wanted to send a file to you, I will throw it. I expect that you catch that file. If you did not, I will not know. If you did not, I will not check after that. If you did not, I will not send you again the file. Yes, that's it. So it's extremely careless. So you want something? Take it. Well, I did not catch. I don't care. I'm going. I'm leaving. That's it. The UDP will leave. The UDP will close the session. So the session will be immediately initiated. The file will be immediately sent with no pre-checks, with no like, no one will clear the throat actually. It will be done in that way. So that's why it's not reliable at all. No steps were performed. It's called connectionless. The only benefit is that it's faster. Like what? Like a video call. If we ever wanted a video conference, a video call, a voice call to be checked with the pre-steps of three-way handshake, then we will have to wait so much time, and we will consume so much delay, or we will face so much delay with transporting the video conference. That's why we will use UDP for voice and video connections. Other examples for that will be like SNMP, which is using the UDP 161. I will teach you what's that in chapter 4. TFTP in chapter 4 as well, UDP 69. DNS in chapter 4 using UDP, not USP, UDP 53. syslog in chapter 4, that's using UDP 514 or 514. So these are very simple examples and basic. For chapter 4, I'm sorry, for layer 4 of transportation, you will not develop anything there. Yes, that is the case. So that's why I don't spend too much time telling you what are those at all. Another thing that I want to tell you in this video, because this video is really short, perhaps you want to pause the video right now and take a break, or perhaps you want to continue. Something simple has been added recently to the agenda of Cisco CCNA. It's called the IP parameters for the client and devices like Microsoft Windows, Macintosh, or Linux. The IP parameters are useful tools making use of the IP technology, the Internet Protocol technology, to achieve some functions or operations that you might need as tools for you only, that you are making use of, like the ping tool. The ping tool is actually a very simple tool that you use it to check the reachability to something. Like, let me type PowerShell in my Microsoft Windows computer, and my PowerShell, or even if I typed like the command line, which is the CMD, whatever you want, both of them are identical, and here or there I can just type ping something like ping www.google.com. If I received a reply, like a reply from an IP, this one is 172 private, right? No, it's not 16, neither 31, not in the range between 16 and 31. It's above 31, so it's definitely a public address. So I'm receiving a reply from a public address, and this address is the address of google.com. Lovely. So I was able to reach google.com. So it's as simple as typing ping and then something. Mostly you will not type ping names, you will ping addresses. Like, I will copy that by selecting that, and then I will type ping, right click. I'm sorry, you should have copied that. Yes, and hit an enter, and mostly in the most cases or scenarios I should ping an IP address. So it's as simple as that. But the second tool says trace route. So to trace it, what is a trace route? Even if I will talk about trace route a lot in chapter 3, 4, and 5, but still, trace route, which is expressed as trace RT-D in Microsoft Windows, is a tool that uses UDP. By the way, ping uses a tool called ICMP, Internet Control and Management Protocol. Here we are using trace route. Trace route is using UDP, and trace route is a tool that will trace for you the route. So I pinged this IP address successfully, and that is nice. But my question is, I'm so curious, I want to know actually what is the path of routers or layer 3 devices that my packet like routed through all the way until it reached the IP address of Google. Because to be honest, I am right now, Sajjad, I'm recording this video from Iraq, from Baghdad, Iraq, and Google.com servers are either in UAE, Europe, or America, closest to me. Maybe they have some servers in Asia, but not in Iraq. So the idea is, or the catch, what I want to make sure of is the path that it will travel. So my packet, when it pinged successfully, it traveled through countries actually, but I just want to know. So let me type trace RT, representing trace route, -D to avoid something called resolving that I will tell you in chapter 4, but just to trace this IP address. So give it an enter. The first IP address is my home router. Something seems the gateway, some private addresses in the way that I don't know, some other private IP addresses, and then I'm going to a public IP addresses that I can see, like 37 and another 37 as well, and then I'm seeing 178. So it seems that we are out of Iraq, because I know this IP address is of Iraq. I can select that. I can go to a web browser, and inside a web browser I can just simply type what google.com, and I will paste IP address, this one, sorry, this one. I need to copy this one, which is 37.236.248.240.18, and list of IP addresses, ranges. It's an Iraq IP address. You can see that, right? It's an Iraq IP address. So I don't want that. No, I want the next one. The next one is this one. Oh, it's continuing. By the way, the trace route is continuing. Let me see this 1780. So this one, are we out of Iraq yet? 1780.8658. And this one is in, let me see, find IP. Where is that? It's in Saudi Arabia, in Riyadh. Okay, again, are we traveling today? It seems that we are. Another one, let me say, well, it says that the trace is complete. Nice. But I will just want to know, wow. This was Iraq, this was Saudi Arabia. And after that, we are seeing a ton, about 8 different IP addresses as well. Wow. The last one was 172. This one. And that is in California. So my poor packet is tired because it traveled from Iraq to Saudi Arabia, and then I don't know this path. Perhaps you would like to trace it by yourself, and until it reached California and America. This is the benefit of the trace route as well. Okay, the third and the fourth tool are called FTP and SCP. These tools are used for transporting data, not for transporting like your packet or session, no, data. Like I'm sending a real image from a server to a server, from a computer to a server, from a server to a router. Like, let me tell you something. In this second chapter, or from now on, like at the end of this chapter and forward, we will talk about, or we will use routers and switches, and you'll see that these devices have software installed on, and this software sometimes might need an upgrade. So this router does not have a DVD drive or an external hard disk or etc. How can I transport the software image to it? 2 steps. Number 1, or 2 methods actually. Number 1, use a USB stick flash, and use a stick. You can have a copy of that software upgrade in that flash, and you can stick it to the router and upgrade that based on a procedure that is not part of the agenda here, no. But perhaps you can do like a small course called maintenance for devices. Second method will be log into the same router and ask it to FTP or SCP. Ask the router to copy the software image from a public server in the internet or from a private server in your environment by using FTP or SCP. So FTP and SCP will be the carriers that will carry to you that data, these data. This will be carried only by FTP or SCP only. And FTP has a flavor called TFTP. That we will talk about that in chapter 4. And actually, let me tell you something nice. These guys, actually, the IP parameters, have a different name called IP services. And chapter 4 of this course is called IP services. So the entire chapter is called IP services. So you will enjoy at that time all of these different services and hands-on labs for ping, traceroute, FTP and SCP perhaps at that time, Telnet and SSH as well, internally and externally. And then we have Telnet and SSH. Both of them do or perform the same feature, which is called remote access but secured, like the data will be encrypted. These can be used to telnet some device or something like telnet. I can just type telnet and an IP address of the 0.1 maybe. Yes, it seems that this one is not recognized. Not recognized. No, it should be recognized actually here. Telnet. But I need to activate telnet there, which is not activated. Yeah, this one is not activated, but it's as simple as telnet. We will have a complete labs for that. Labs are not for chapter 1 at all. Labs are for chapter 2, 3, 4, 5. And yes, 2, 3, 4, and 5 labs are there. So there you will find multiple labs for telnet and SSH, and that is nice. ipconfig is given IP address for your computer. Like I can go again to the CMD and I can type as simple as ipconfig. If I type nothing, then it will show the IP addresses that I have. Otherwise, like ipconfig again, I can type the IP that I want to configure, and that's it. Okay, so the rest of the slides that you want to see are the examples of the commands. Like if you want to ping something in Windows, you type in the terminal of Windows ping something, and you have seen that in action. In Mac OS, there is a terminal window in Mac OS as well, ping something. In Linux, there is a terminal in Linux and you'll have to ping something. The commands are ping and IP address. And for traceroute, then how many slides I have? Only 2. That is enough. Yes. Let me drag that. Okay. For traceroute in Microsoft Windows, you can use the terminal or the CMD, the PowerShell, and you can type either traceRT or traceRT-D and then the IP address. So either traceRT, the IP address, or traceRT-D, the IP address. In Mac OS, you will need to initiate the application that is called network utility and type immediately the IP address and then dash and then trace. It seems in that way. In Linux, in the terminal, you have to type the entire word of traceroute and the IP address as well. For Telnet and SSH, some of them are supported in the terminal. Others requires a software to be installed like Homebrew or Secure CRT or PuTTY. We will talk about that furthermore in chapter 4. So I hope that everything was clear for you in this video, because in this video we talked about 2 topics. We covered 2 topics today. The layer 4 transportation protocols like TCP/UDP and the IP parameters. I hope to see you in the upcoming video. Thank you.